Welcome to the Maths panel. This lesson is on number bases and math skills. Don't forget to subscribe and follow the lessons detailedly. We begin with the concept of number bases. To take some examples, to convert from one base to base 10, there are two steps to insert powers beginning from 0 and moving towards the left, that is from right to left. Secondly, we expand and simplify the number. Let's take this example. To convert 345 base 6 to base 10, you write down the 345 base 6. There are 3 digits, so you insert powers from 0. The first will be 0, the second will be 1, and the last one has a power of 2. Note, it is from right to left. Then we expand 3 times 6 to the power 2. We are using the base to expand, just like in base 10. The next plus 4 times 6 to the power 1 plus 5 times 6 to the power 0. Or for the last digit that carries a power of 0, you can just write plus 5. It's okay because 6 to the power 0 is 1. We now simplify. 6 to the power 2 is 36, not 12. So we have 3 times 36 plus 4 times 6 plus 5 times 1. And when you sum all these, it will give us 137 base 10. If you write the answer without putting the base in base 10, you are correct, because everything we are doing in normal life is in base 10, except the base is indicated. If the base is not indicated, it means you are working in base 10. Equally, note, the digits in base 2 are just zeros and ones. In base 3, you have 0, 1, and 2. It therefore means a number cannot be in base 2 and you find a digit of 3 in it. The highest digit in base 2 is 1. The highest digit in base 3 is 2. The highest digit in base 4 is 3, and so on. And the highest digit in base 10 is 9. So you can have a number like 1, 0, 0, 2, 0, 1, 0, and so on, base 2. The highest digit in that number can never be more than 1. And in base 5, you can have 4, 1, 3, 2, 1, 0, and so on, but you can never have 5 in base 5. So note. Then, to convert from one base to base 10, as we have just mentioned, you insert the powers, expand and simplify the number. Let's take another example. Convert 10112 to base 10. So you write down the number, insert the powers beginning from 0 and from right to left, so you have 0, 1, 2, 3. We now expand. The first one will be 1 times 2 to the power 3 plus 0 times 2 to the power 2. You can skip this one because it's 0. You know the value is going to be 0. This one can be skipped. It's still correct. Plus 1 times 2 to the power 1 plus 1 times 2 to the power 0. Note, you can just write 1 because 2 to the power 0 is 1. So we simplify. We will have 8 plus 0 plus 2 plus 1. And that gives us a value of 1 base 10. Now, to convert from base 10 to any other base, these are the rules you have to follow. You have to divide continuously by the new base. And at the end, when you have finished your division, you take the remainders and you read those remainders from bottom to top. Let's take an example to illustrate. Divide continuously, read the answer from bottom to top. Convert 15 base 10 to base 3. So I'm going to divide continuously. 15 divided by 3 gives us 5. The remainder is 0. The remainders are very important. 5 divided by 3 goes once, remainder 2. And 1 divided by 3 gives us 0, remainder 1. When you have 0 remainder anything, it means you have come to the end of the continuous division. You can now read your answer from bottom to top. And this will give us 120 base 3. Another example, you have convert 13 base 10 to base 2. Continuous division, we are dividing 13 by 2 continuously. 13 divided by 2 gives us 6, remainder 1. 6 by 2 gives us 3, remainder 0. 3 by 2 gives us 1, remainder 1. And 1 by 2 gives us a value of 0, remainder 1. When you get to 0, remainder something, then you have come to the end. So our answer, right from bottom to top, will give us 1101 base 2. Let's move to the next part of this particular sub-lesson, which is on scales. Let's take this one example, the past question, before we move on to the map scales. Example: if 24 base x equals 16, find x. Here you must note that this 16 is 16 base 10. The hint here is that you have to make the bases the same, and it will be easier for us to convert everything to base 10 here, not to base x. In fact, always convert everything to base 10 when you have such type of questions. So 24 base x to base 10 will give us 2 times x to the power 1 plus 4 times x to the power 0, or just plus 4. This will give us 2x plus 4. Now that the bases are the same, this number is now in base 10. You can now equate the bases. So 2x plus 4 is equal to 16. 2x will be equal to 12 when you subtract 4 from both sides, and x will be equal to 6 when you divide both sides by 2. Another example, you have if 1y base 8 equals 12, find y. Note equally that the 12 here is in base 10. So we convert everything to base 10. We will have 1 times 8 to the power 1 plus y, or plus y times 8 to the power 0. This will give us 8 plus y. Now this number is in base 10 and is equal to 12. So our y will be equal to 4. We can now move to the second part of the this sub lesson, which is on scales. In this lesson, we'll be looking at map scales, linear and area scales. It is difficult to draw the exact length of a road or size of a city on a paper. Therefore, a scale is needed. Similarly, you cannot have a paper to draw your house exactly as it is. Therefore, we need what we can use to actually bring that real life diagram on paper. And here, the concept of scales comes in. A scale of 1 to 200 means 1 unit on map represents 200 units on land. If I'm working with centimeters, I'll say 1 centimeter on the map is equal to 200 centimeters on land. If it's centimeters, it should be centimeters. Or 1 meter on map represents 200 meters on land. So linear scales, because there are two main types of scales we are looking at. We have linear scales and area scales. For linear scales, it is all about length or distance. About length or distance. If 1 centimeter on land represents 5 meters on land, the scale will be written as 1 centimeter to 5 meters. But this scale has not been simplified because I am seeing centimeters and meters. So I have to actually simplify to make everything to be in either meters or centimeters. It will be good for me to make everything to be in the smaller units so that I can easily divide. Alright, so in this case, I will have 1 centimeter to 500 centimeters. Note that 100 centimeters make 1 meter. Therefore, 5 meters is 500 centimeters. And we can cancel out the centimeters and you'll be left with a scale of 1 to 500. Equally, 100,000 centimeters makes 1 kilometer. Let's take another example. On a map of scale 1 is to 5,000, the distance between towns A and B is 80 centimeters. Find the actual distance in kilometers. So the scale has been given as 1 centimeter is to 5,000 centimeters. Therefore, 80 centimeters on the paper represents how many centimeters on land we solve for x, and that will give us 400,000 centimeters. The answer is okay, but now the question requires us to give our answer in kilometers, and from the recall below we know that 100,000 centimeters makes 1 kilometer. So we divide by 100,000, and this will give us a distance of 4 kilometers. When you take the quiz, you will see questions like this, and even past questions. Another example: to find the real or actual area on a linear scale, you either multiply linear scale by itself, or you find the real length and the real width and calculate the area. Like we mentioned before, there are two types of scales: linear scales and area scales. When you are working with areas, what you need is an area scale, and an area scale is given by dimension times dimension. Know that area is length times width for short, depending on the shape. So if actually I am giving an example like this one, example 1, on a map of scale 1:100, a rectangular plot of land measures 6 centimeters by 4 centimeters. What is the actual area of the plot? What I have to note here is the scale that has been given is a linear scale. I can answer this question in two ways. I will find the real length. The real length will be 6 centimeters times 100. So I have the real length, which is 600 centimeters, and the real width, 4 centimeters times 100. That the 100 is from the scale. That gives us 400 centimeters. Now the real area will be length times width, which is 600 times 400. That gives us 240,000 centimeters squared, or squared centimeters. I can equally decide to give my answer in meters. Here the real length will be equal to 600 centimeters, which is equal to 6 meters. Real width 400 centimeters, which is equal to 4 meters, and the area will be 6 times 4, which is 24 squared meters. Or I can find the area scale. Area scale is given by linear scale times itself. So 1 times 1 is 1, and 100 times 100 is 10,000. So the area scale is 1:10,000. I will now find my area on the map, which is 6 centimeters times 4 centimeters, and multiply this area by the area scale. That gives us times 10,000, which is equal to 240,000 centimeters squared, and it gives us the same answer. You can divide by 10,000 rather, to have the area in square meters. Method 1 is preferred. Thank you so much, and don't forget to subscribe as we move on to the next lessons that will look at standard form and a few tricks in numbers. Thank you so much. Stay tuned, and bye bye.